Welcome to another episode of the AI in Manufacturing podcast here on Industry 4.0 TV. I'm your host, Kudzai Manditereza. And in this episode, we will discuss time series, data quality, and reliability for AI applications in manufacturing. And my guest on this episode is Bert Baeck, who is the co-founder and CEO of Timeseer.AI. Bert, thank you so much for joining us on this show today. Welcome.
Thank you for inviting me, by the way.
Absolutely. Yeah, so I mean, you've got really, as I was going through your sort of like your biography, you've got really an illustrious career, founding companies up until what led you to found Timeseer.AI. Could you maybe start by telling our listeners a bit about yourself and give us your background and what ultimately led you to found Timeseer.ai?
Yeah, so from background, I'm a computer scientist, so I have a major in computer science. Early on, we called it data mining when I was still at school. I started my career in the chemical industry. The company I worked for was Bayer, that broke up into two companies, Lanxess and Covestro. And there was my first experience with sensor data. We are now 2005, 2006. And the early days of getting value out of Pi and experimenting with alarm management and writing scripts on reducing the alarm loads. That was my early career. And then quite soon, I had a dream of becoming an entrepreneur since I was a child. And I was indeed following my dream. And I started a company called Trendminer. So Trendminer, I started a company 2008, and that company was sold in 2018 to Software AG. And there we were one of the companies next to Trendminer, and you had Seek, and we were both pursuing the adventure of self-service analytics. So, for example, the moment when we sold the company in 2018, we already had like 10,000 plus users. 50% of the global top 50 chemical industry was using Trendminer, so it was a real great journey to be in. And then after I sold the company, I left quite soon after the integration, because if it's not your company anymore, I'm not good in working for big companies. I'm more entrepreneurial, and I started, becoming a partner for a venture capital firm here in Europe, in Belgium, where I'm living, by the way. And I was a partner doing the investments in everything related to IoT, industrial analytics, machine learning, and AI. And there I got intrigued by the new category, information data quality. So we're going to talk about that more today. And because of a lot of companies stood up, got investment in that category, a lot of them, and a good funding amounts. And there was really nobody really focusing on IoT and OT data, so sensor data. The founding team I had with Trendminer, we had a lot of experience with sensor data. And for us, it was like a logical choice to say like, okay, let's jump back in the trenches as entrepreneurs and let's build that data quality platform specifically for IoT, OT data, so time series. And each co-founder joining me in this company we all have like 10, 15 years of time series experience with data. So it's a great head start to start a company. And that is the why. Like if you looked where we are in the ecosystem, we are activating data, we're consuming data, we're building dashboards, building twins, AI models. And this is the moment where data quality starts to matter, because if people start to use or rely on the decisions or take actions on top of it, that's exactly the moment in time where the quality needs to be perfect, right? And that's why we made the bet, like this is the time to build a data quality company. And that's how it goes in technology. First you build an app, and when the app is maturing and it needs a certain element, it becomes infra. And that's exactly what data quality. Data quality was a feature for a lot of analytics companies, and now it's becoming the platform, it's becoming the infra. And that is a little bit where we are taking a bet on.
Yeah, absolutely. Yeah, I mean, I'm really looking forward to unpacking, my data quality with you today, because this is also for me such a fascinating, topic. So I've been in the industry of IoT, IoT, for almost close to 8 years now. And it's only recently that everyone in the community really started to pay attention to, data quality, right? No one
Yeah.
really, paid that much attention. And if you also, this is something that I also, talk about often here on this show, that if you read a lot of reports, you know, about, the AI, implementations in industrial or manufacturing, where you see like 80 to 74% of pilots are said to fail, right? So like all AI sort of like pilot, they fail to scale, out of that phase. And what's fascinating about me, about that for me is that of all those reports, actually, even just yesterday, I was reading, a report by MIT where they said 95% of generative AI projects are failing to, move out of pilot phase. And there's one common element to all of those reports: data quality keeps coming up as the main culprit. So it's where it's reported to about 80% of AI projects fail before because of that. So what I'm curious to find out from your experience is, what are the primary sources of data quality issues in industrial environments, and why exactly are companies struggling with this?
Yeah, I think it's clear indeed that most AI projects are not failing due to bad models. They're indeed failing because of the data is lying. So data quality, like you say. If you think about the lineage of when we talk about sensor data and an instrumentation and assets and connected elements in the field, IoT and both OT, a lot can go wrong, right? So if we now talk wired, wireless or wired, still you talk about a sensor measuring something, and you can have problems with your data acquisition system. You can have problems with your infrastructure, but very often it's the data from the sensor itself. It's not reliable because of things like outliers, jumps, gaps in the data, unexpected losses of the data, but also like subtle drifts over time, miscalibrations. So a lot can go wrong due to the physics of a sensor. And if that all can happen, and then you have like thousands of sensors, and that's exactly what you see there. And data quality is an afterthought because, and that's a little bit, that's the nuance of what we're doing. For operations, where they are producing something, they don't have a data quality problem. For them, the data is good enough for operations because they have a control system, an alarm system, a safety system. Often they have a human in the loop to watch out of the alarms and make corrections. And that's all in real time. And data quality is a problem when it's stored and it's stored over time. And that becomes a problem for the people picking data up for consumption, for building dashboards, AI models, or stuff like that. But that means for operations, they don't have a data quality problem, or they don't think they have it. And that means that is the real difficulty in this industry, because it starts an operation, but they don't see the problem.
Oh, yeah, absolutely. And I mean, I think one thing that I find interesting is that we are now at a stage where, almost every industrial company understands that, they need to make data, the primary sort of like asset, right? And what's interesting, as you have said, previously in some of your content, is that, it's easy for data quality to become sort of like, for data rather to become a liability,
Yeah.
particularly when AI maturity is pursued without ensuring that data quality aspect that you spoke about. Can you maybe elaborate more on kind of like what you mean about data becoming a liability?
Yeah, great point. Unvalidated data isn't an asset, right? It's a liability dressed as an insight. And what do I mean with that? Um, if you're scaling analytics without data integrity, in the end, you end up with wrong decisions, low efficiency of AI projects, no repeatability of your data projects. And trusted data means like you're checking your data upfront for quality, data monitoring, data observability. When you do that, typically what you see is that your analytics projects become repeatable, scalable, and indeed you will see a sort of an efficiency in scaling use cases. And what I mean, if you just are scaling up analytics, investing in AI, investing in analytics, investing in dashboards, at one point, without taking into account data quality as a feature or as a platform or even as a methodology, you end up with scaling, and you will end up with in a situation where it's totally unmanageable. People will take too much time in correcting, you will make wrong decisions, dashboards not reliable, and we've seen indeed companies where we work with that abandoned AI analytics projects or said like our dashboards, people don't look at it because they just know the data is not reliable. So it shouldn't be an afterthought, it should be something you incorporate at the design phase. And indeed, what I mean with that, with the liability part, is if you don't do it, it becomes a liability, especially if you force people to make decisions on top of data. How can you make decisions if you don't know if the data is reliable? And that's what indeed the link between an asset and a liability.
Oh, yeah, absolutely, totally agree with you there. So, I mean, I've worked before in the industrial space, and certainly, if you can't trust a system, no one is going to use it, right? So you invest in these data platforms, but no one uses them if they really can't trust them. So I think 100% agree with your point there. And I would like us to sort of like talk about one of the other, terms that you frequently use, which is, data downtime.
Yeah.
And you've kind of like you've got this way of, describing how data time, sort of like how the cost of data downtime can escalate from $1 at detection up to $100 on operational impact. So maybe first of all, can you help us understand what data downtime actually means in the context of manufacturing, and
Yeah.
then how can sort of like manufacturers start to quantify this risk within their own operations?
Data downtime in essence is when your plant or sensor or asset looks fine, but the data underlying is lying or is wrong. That's the definition. The reason why we came up with that word downtime is of course inspired by buzzwords like OEE and production downtime, but not downtime from an operation, but downtime from your data. And if you look to the definition, basically the downtime of data is where you cannot trust your data. That can be because of data is missing, not reliable, gaps, so all the things that can go wrong. Basically, when your data is not representing the state of the asset or the sensor, that is data downtime. Because when I will pick it up later on, it's wrong. It's not representing the state of that element or that sensor, and that is what we refer to as data downtime. To your question on the 110, 100, basically is when you have an issue or you detect an issue, for example, a calibration problem or a replacement or a quick intervention or even a reset. When you do that, when it's notified or the software picks it up that you have a problem, that is the $1. It takes you $1 to monitor it, right? That's the whole reflection point. If you don't do that, and suddenly you discover it later in analytics or in dashboard and or in compliance, or it ends up in a billing flow where the data is used for billing and it's wrong, that needs to be repaired by someone. That is already ballooning up to $10 to $20, for example, because someone spends time on correcting it. And that's a shame, because if it would be flagged up front, that's even reactive, because you pick it up too late and then you have to correct it. And that is why it becomes already more expensive. But it goes further. I said, like, for operations, maybe data is good enough to operate, but if indeed what you see is if that sensor is drifting and or flatlining, and flatlining is a good example. If a sensor is flatlining, it means a flat data point within its normal range, so it looks like it's perfectly normal, but in the end the sensor is broken. We have an example where, for example, where a client of us that flatlining sensor ended up tripping a compressor because the logic failed, and that logic failing led to a production downtime. And there I make the link to $100, because you could have picked it up that the sensor was flatlining for $1 for monitoring it, but you didn't do it, or you corrected it, that was expensive, or it led to a problem in your operations downstream, and that's even more expensive. And when that data downtime leads to production anomalies or abnormal situations or unsafe situations, their balloons from that $1 to $100. It's more to say like, okay, it's a missed opportunity. Now it's cost you so many money, and you could have prevented it by just monitoring your data at the source. And that is a little bit how we treat data downtime and why it balloons to higher numbers.
Yeah, that's really fascinating and kind of like really understand this concept of a data downtime. And we're going to get into how sort of like your observability, platform helps you to kind of like detect all those and eliminate those downtimes. But before we go into that, I kind of like want to get your take on this idea that sensor data or time series data is fundamentally different from relational data, especially when it
Yeah.
comes to ensuring data quality. Can you explain that difference for us, and why do traditional data quality tools fail when it comes to handling time series data?
Yeah, well, relational tools, they check tables typically, right? We don't need tools that check tables, we need tools that understand physics. If you talk a sensor, you talk first principles, you talk physics. You're measuring something, a flow, a pressure, a temperature. And the nature of time series data is that different, and you also have then also the point of causality. Maybe a flow is increasing and it can have an impact where also temperature 1 hour later will increase. So the nature of time series data is completely different than tables. And there's the whole paradox. Classical data quality tools that are managed by data teams, typically IT centric, for them, the data often looks normal. What do I mean with that? Well, they check if the data is fresh, this data is coming in at a normal rate, and if the schema, for example, of the database hasn't been changed. If that is valid, for them the data is perfectly fine, right? But maybe that same data flowing in from that sensor or thousands of millions of sensors is behaving strangely. Things I already mentioned, like you can see outliers, flat lines, and normal ranges, but also subtle things like oscillations, subtle drifts over longer terms. I can name so many things that can go wrong, and they are depending on the physics if it's okay or not. Indeed, if you refer to drift, if you detect a subtle drift, well, it can be maybe that your sensor is degrading, aging, the fouling, a lot can go wrong. But again, for IT, the data looked perfect because the schema was perfect and the data came in at a normal rate. And that indeed means why sensor data is different, because the IT stakeholders, they cannot judge that all the time. They need to go to the operations people or to understand that sensor to judge, oh, is the sensor now reliable in this situation? Yes or no? And then indeed you have the most important thing here to extra mention is you talk data quality. Data quality has a narrative of it's an IT thing or it's a data thing. But if indeed a sensor is flatlining, and that flatlining is because not because the data is not coming in anymore, the sensor was really broken. Whose problem is that? Well, the sensor is broken, somebody needs to repair or needs to replace it. That's again an operational problem. It needs to be replaced by the E&I persons, the instrumentation people. And that's not data quality, but it's detected by a data quality platform. And that is why indeed it's so a different animal, and that we cannot expect modern data quality tools to play a role in the OT or in the IoT stack, because it has a dual role there. Like I said, it can be a pure data problem, yes, but it can also be a sensor problem, and that can only be judged by people understanding the data. And that is the difficulty in treating sensor data.
Yeah, absolutely. And I think that kind of like gives us a good segue into, talking about your Timeseer, .ai data observability platform, to get an
Yeah.
understanding of exactly how it, sort of like, fills that gap. So maybe first of all, could you kind of like give maybe an introduction, to our audience on what is, Timeseer.ai, and then kind of like paint a picture for us, where does it sit within like an existing manufacturing's architecture, where you have got many things like your OSI Pi, your Azure, all these
Yeah.
data platforms.
I always say we sit in the trust layer in between storage and consumption. When we talk storage, where do we store time series data? Well, indeed, you mentioned Pi, Aviva Pi, the industrial on-prem databases, but also often now cloud-oriented data structures, Databricks, Snowflake, Azure, Amazon, they all have their stores, their cloud warehouses. So data is stored everywhere, but what we typically see is that still 95% of the clients we work with, they store their data in a more older industrial historian environment, typically on-prem in their own tenants. And then indeed, when the data would be picked up for analytics, they would store it or copy it to a cloud environment. So we see that data is stored everywhere, but mainly still today, we see industrial historians as the main source. That is the storage side. If I say we sit in the trust layer, that's the storage side. The consumption side is where data is already used. What is done today with data? Well, people are building dashboards in Power BI. They are doing self-service analytics, indeed, with tools like a Trend Miner and a Seek. The data engineers, they pick it up, and data scientists, they manipulate in Databricks because they want to make a model, or they have other ML ops toolboxes. It can be going to SAP or to an MDM system because it will be used for billing. So a lot has already been done with the data, and that is the consumption side. And if I say we are in the trust layer, the evolution that we are seeing is if data quality was a part of the consumption layer in the analytics stack, it was a feature. And what you now indeed see is that data quality is shifting left. It's a movement. If it shifts left, that means it is shifting into the middleware, in between the storage and the consumption. And indeed, that is an evolution we're seeing, because if indeed every tool, every analytics application, every platform will tackle data quality in itself, you end up in chaos, right? Because what companies want is one single version of the truth, and that is only happening when you check data quality somewhere as a central element in your analytics equation. And that is indeed why it's shifting from the consumption side into the middleware as a full-blown building block. And that's why I'm calling it the trust layer, because that's exactly what it is. If data quality sits in the trust layer, it means every party or every tool downstream from us, for example, has the guarantee that data is checked for reliability, cleaned, validated, and that means that you have a sort of an SLA, a service level agreement, where you know when I pick up data, it's checked by Timeseer. It should be reliable because it's verified for trust. And that is indeed why we always say we sit in the trust layer.
Yeah, that's really interesting. And I suppose by sort of like, the trust layer, actually, as you have, just, described it here, it's really, you're really talking about, pushing that, data quality check right to where the data is originating from, wherever it's coming from, right? Because as you mentioned, traditionally you'd have a situation whereby, like, companies will just collect all of the data raw, unchecked, and validated. They put it into a central data lake or data warehouse, where you've got a data science team that then has to sort of like try and clean that data up. And then your approach is to say, instead of doing that, you sort of like push that out, like as you mentioned, shift it left to kind of like, right at the originating sources. Can you kind of like maybe, sort of like elaborate more for our audience on why that, matters so much, particularly in industrial automation or industrial
Yeah.
environment?
We scan data where it's generated, not in the cloud, because if you wait until it's in the cloud, the damage is already done. That is the essence. What do I mean with that? Is not all data will move into the cloud. What data will move to the cloud indeed, or in the cloud warehouse? Well, the data that's used indeed today already for indeed dashboarding, AI models, twins. But that doesn't mean the other data is not important. And what we see as an evolution is that clients, they want to scan data where it's residing, because they don't want to move data first to a central place where it can be scanned for quality, because it's not sure if they're ever going to use that data for downstream analytics. And that means it's really a requirement that you can scan data where it's generated. And then that's often indeed industrial historians on-prem. You can compare this with like a virus scanner. You're scanning a viruses where the viruses arise, right? And the same happens for data quality. you're scanning the data quality where data is generated and stored for the first time. And that means it's not just something you do in a cloud environment, pure SaaS, because then you miss the essence of what we're trying to do. Because indeed, if we refer back to your earlier question, it can maybe that one data point or data stream is not used in analytics, but Timeseer picked up that the sensor is broken because it was drifting or it was flatlining. That's valuable for operation. And that's not because that data wasn't used for a model or a dashboard, that it wasn't a valuable insight. And indeed, that's why we are scanning data where it's residing at scale. All your data, not just the data that being manipulated into a cube or a data bricks or a warehouse. All the data is scanned where it's residing. Because like I said, if you wait until the cloud, you're too late. Damage is done.
Awesome. Yeah. So I guess maybe to make it concrete for our audience, let's kind of like walk through the actual makeup of your Timeseer.AI platform. So
Yeah.
your platform is sort of like composed of these four core components where you've got your scoring, monitoring, cleaning, and uniformization. Can you maybe just kind of like from the ground up explain to us, what's the makeup of Timeseer, and how does sort of like the data, the transformation of data from the source up until to where the destination, all these different stages, how does your platform sort of like contribute to making the data more reliable?
Yeah. So indeed, we turn raw signals into trusted assets through basically four steps: scoring, monitoring, cleaning, and uniformize, like you say. Breaking down each element, scoring. The first step is when you're indeed scanning data where it's residing, you need to make an estimation, or you need to verify for the data that's being generated if it's reliable, yes or no. That's basically like a thumbs up, thumbs down. Is it reliable, yes or no? What problems do we find? Typically, it's not one problem, it's many problems. So you need to profile the data to make an abstraction on saying is data reliable. This boils down to checking a baseline, QA, quality assurance. You need to assure if the quality is there. If not, you need to tell the user what's going wrong with the data. That's the first step: assessing, benchmarking, profiling, verification, all in one kind of layer, where indeed you provide the insights to just say to the data people if data is reliable, yes or no. A second step is, so data quality
And,
or data, yeah,
sorry
sorry,
to interrupt. So
yeah,
maybe before we go into the second step, I'm
yeah,
kind of like curious to find out how sort of like especially with the scoring aspect of it. What's typically the process that's involved there as far as coming up with the benchmark, especially if you're moving from a situation where you know sometimes manufacturers may not know that this actually sensor is this is actually going through downtime,
yeah,
or
yeah,
so how do you sort of like come
yeah.
up with those benchmarks?
That's a good question. Indeed, how do you? Your question is how do you score? Well, like I said, data from time series is different, and it boils down to physics. And luckily, we understand the physics, we understand the specifications, we understand that the flow is different than a pressure and a temperature, and we know what can go wrong with each kind of element. And indeed, what you need is a definition of what can go wrong with the data. And what we do at scale is indeed we have like 100 to 200 kind of data checks, all developed for time series, where you basically are just checking all what can go wrong. Stuff like outliers, impossible jumps, gaps, not the numbers, drifts, anomalies, correlations that are suddenly broken, impossible jumps. So all the things that can go wrong with sensor data, we are checking at scale for all the data. And in the end, that is the assessment layer, because what we basically do is for all the data, check what is happening, what is going wrong, what do we see. That's the profiling step and the assessment step. But we're checking everything that can go wrong and then report on that. And that's your baseline. That is just, for example, we scanned your data historian of Pi of the last year and we find all these problems. You just report on everything we find in the data and you communicate, for example, with a heat map where people interactively can look into the data, what kind of defects that we found, and what is explaining the downtime of the data. That is the first step indeed. I hope that's more clarifying,
Yep,
but you
absolutely.
do it by checking a lot of things for all the data.
Yep, 100%.
Yeah. And that's static because that is something you do, for example, of last year. But what if indeed data is generated every day, every new data comes in? So
Mhm.
data quality is not something that can be done one time. And that is where data quality assurance moves into data monitoring. The difference is you're checking data quality every X. What is X? Every minute, every hour, every day, every month, every week. It depends on the use case. For example, if you're running an AI model and you want to know if the AI model is reliable with the input data, you want to check every minute if you can trust the data from the sensor. If you just want to know if your PyHistorian is running reliable, it's maybe good enough to check every week, every day, and to check and do a quality assurance step. So data quality monitoring is very dynamic and it depends on the use case. Um, and there indeed we moved from QA, quality assurance, to data monitoring as an important step of how we work with data quality checking. You're checking it dynamically. The third step here is if we flagged or picked up problems, like indeed we picked up data downtime or data defects, and the data will be used for something, used for a report like energy dashboard from all your plants, or for billing, your billing flow to your clients, for consumption. And that means somebody needs to repair the data because it was not good. And indeed, you can do two things. We can clean data. That means we are using algorithms to estimate what the likely version was, or we can take the most conservative version depending on the use case. But often, if it's really critical, we are doing it interactive. That means our data stewards or data analysts from the clients, they look to the data and they are correcting it. So data cleansing is something, and validation is something you do dynamically. An outlier, oh, remove the outlier. That's simple. But indeed, if your gap is too long, we don't know what the solution is because we are software, we have intelligence, but there's a user from the client that needs to make the call. How am I going to fill in the gap? So you see, like data cleansing and data validation, it goes hand in hand, but there's like not a clear cut. Some things we can clean. When the cleaning becomes too complex or the gap is too long, somebody needs to look at it. And that flow of validating, cleansing, repairing a user automatically, that is the third step in Timeseer. That is our interactive data validation flow. And that's typically being done on a daily basis. So we have, for example, clients in utilities who are billing the water consumption from entire municipalities, communities. And when your water consumption is wrong for numerous reasons, they are checking the data. We flag when data is not reliable. We check the data downtime, and they are repairing it where Timeseer is not confident in the repair. Like I said, as an example, when that gap is longer than a day, we cannot fill it in because it's too long. Somebody needs to look at it and needs to repair the data. So helping in the repairing flow is a third step in Timeseer stack. The fourth step is if you profiled, verified, monitored, and then you cleansed it and validated it, there is typically data will be used for consumption. Like I said, in a report, in a twin, in an AI model, and for that specific reason, what we see as a use case is that our clients, they want to set the requirements or the requirements of the data. For example, I want to have a guarantee that my data is 99.9% fresh. I cannot have gaps. I don't want drifts. I don't want oscillations. So you're making a definition of what you expect from quality, and you're monitoring against that. That is the part of service level agreements where you're guaranteeing the data if it's reliable, yes or no, and not. You will flag it and you will present it as, look, the data that ended up in that dashboard wasn't reliable. So you're monitoring against a service level agreement, and that indeed is the uniformization step, and that builds Timeseer in the four steps. Like I said, profiling, verification, monitoring of data, cleansing, validation, and indeed the SLAs. The protected data step is the fourth element in our platform. I hope that's quite clear.
100%.
Yeah.
That's very clear. So I guess maybe, one thing that I want to find out from you is, I mean, as you sort of like may know, so generative AI, AI agents and some time series foundation models are really transforming, a lot of industries. So I wanted to get your sense on how do you see sort of like the role of these technologies, generative AI and some time series foundation models, sort of like how they play a role in enhancing data quality.
Well, not to be honest. What do I mean with that is we have R&D, like AI development is quite core to our of building times here. We have AI engineers, but we've checked all the available time series models, the large models for time series. A couple of examples: Times FM, Chronos, Morai. There are numerous of them. And what we found out is not regarding the benchmark, but the amount of data they are trained on, it's too limited. For example, the biggest one we found was trained on 1 billion samples. That's just not enough. We have much more time series data already from
Oh, wow.
clients. So it's the time series models out there are just not good enough, and often also like not related to industrial environments because they don't share the data because it's confidential. So they are more using available time series data like weather data, atmospheric pressures, but really like core to industry. There's no single time series model at the moment available that could enhance what we are doing. And that is why we are training our own AI. So we're training our own AI, not using LLMs, because that language models are typically for other kind of purposes, and also not using generative AI available because it's not helping us to our mission of bringing trust in data. So I hope one day we found those big models that can help us improving, but today we're not effectively using them because they're not supporting us in our mission of building trust into data.
Yeah, I mean that's super, interesting to note because currently, we have got a whole lot of, people sort of like kind of like jumping into generative AI agents. So that's interesting to hear your
Yeah.
take on how that's, currently not working for you. Yeah, so again, to give our audience a clear picture of the kind of use cases that utilize Timeseer AI platform. Can you share some real world examples of manufacturers who have implemented your platform, and maybe what kind of results are they getting from that?
Yeah, so our customers, they save millions not by smarter models, I think that is already being made clear, but by catching lying data. So catching the data that's lying or wrong early enough. From reactive, typically they found problems later on, reactive. Moving that from reactive to proactive, that's where we build value. If we break down use cases, we see three buckets of use cases. A first use case is bringing efficiency in people's journey that are working or manipulating with time series data. People like data engineers, data scientists, people who are already cleansing, pre-processing. For those people, we bring efficiency. We improve their workflow in cleansing and pre-processing by doing the heavy lifting for them. That is the first bucket of use cases. The second bucket of use case is where we are used as a building block. So indeed, when people are building analytics, they're gearing up a stack of how they're going to approach analytics. And indeed, data quality cannot be an afterthought. It's more and more a design element, where indeed we are used as a building block in building their analytics. That's a second use case, Timeseer as a building block. But the third use case, and that is typically where the biggest monetized dollar or euro value is remember when I was saying that data quality and data anomalies of sensors are quite related?
Mm-hmm.
Well, if we are monitoring the data and checking what can go wrong with your sensors at scale, we pick up very early anomalies or broken sensors or failing sensors or drifting sensors that need to be repaired. And because you do that very proactive every day, every couple of hours, that is the biggest value, because by doing that, we can link Timeseer consumption or Timeseer usage to losses, preventing losses. That means that we prevented down. We have examples where we prevented downtime, where we prevented an asset going down. We prevented unsafe situations. But also things like we prevented a customer being built wrong. So we have numerous examples, but because we check the anomalies at scale for those sensors, the biggest monetized value comes from indeed from preventing things that can go wrong downstream in your operations.
Yeah, absolutely.
Yeah.
Yeah, so I think I would kind of like want to, address the issue of, scalability that I
Yeah.
mentioned, at the beginning of this talk, where I think this is still, one of the biggest challenges where not only for, data quality management, but for a lot of industry 4.0 projects where, companies are able to prove, a concept maybe on a one line or one machine, maybe to use your example of your platform where you're able to sort of like score, monitor, and clean and sort of like uniformize one machine or one line. I want to get a sense on how difficult or how easy it for you to then scale that across an entire enterprise for all the machines to be able to do that at scale. Can you kind
Yeah.
of like paint a picture for us on what that journey looks like?
Yeah, well, if you isolate on one machine, or let's start with where the problem started. So
Hmm.
if you did an analytics project or an AI project for example, for predictive maintenance, we try to, or clients try to predict failures from machines. A lot of the times they strived for the perfect model, and it came with services or work done by data scientists building the perfect model, and that's typically iterative. Cleaning is iterative, pre-processing iterative, but also tuning a model iterative until you find the right fit, the right model. But what a lot of clients found out when they found that great model for that one asset, and they didn't have like one compressor of this, but you have hundreds of compressors of the same asset, copy pasting the algorithm or model didn't work. Why not? Yeah, because the data looked different. The data
Hmm.
could have different problems. So copy paste without a data readiness level was is very difficult. But also like, and that is where you need to make the trade-off. Um, don't compromise, and you need to bring your baseline quality to a certain level. It means when you're building and scaling analytics, you know that the model can be trained on good data. Data looks the same for every asset, and you can expect similar kind of quality. If that's already in place, you have a higher chance of scaling analytics. That's the first kind of degree. But often what you also see is that you need to build simpler models, but combining analytics. What do I mean with that? Well, you can check if a valve was sticking, if the travel times would be abnormal, in combination with, did I say oscillation, in combination with was a correlation broken. So if you really want to scale analytics, you need to make a compromise on your sophistication level. And that is really like the essence of scaling analytics. You cannot expect the perfect model to scale. You need to build your model different, and you build models different by just stacking a lot of data checks you do on the data, like things we do, and combining that in your intelligence layer. But building that perfect model when it would take a lot of time from data scientists, well, it will never scale. You need to make compromises in how you what you check and how you check it, because if you build for scale, you build different, and that's the whole thing. Striving for the perfect model will never scale, but it will help if you have the right data readiness level. I hope that's a little bit clear, but you cannot expect something to scale with the perfect sophistication. That's impossible.
Oh, yeah, absolutely. That makes total sense. It makes a lot of sense. So I mean, I've got an organizational question that I think a lot of our listeners are sort of like struggling with, and also this is something that I've experienced, sort of like working with some digital manufacturing teams, particularly when it comes to the issue of data quality. As you mentioned, data quality has for a long time been something that belongs on the IT side. From the OT side, we have never really sort of like paid much attention to it, and that kind of like leaves a question to say, who should own the quality of OT data? Is it IT's responsibility, or should it stay with OT, or how does it, is it a hybrid role that needs to be sort of like handed this task? How who should own this?
That's such a great question. Um, but your question, who should own it? I think it should be owned by operations. Um, Operations, why? Because they understand the data. So at least it should be owned by someone who can judge if indeed that sensor signal was reliable, yes or no. So that means it can never belong to pure IT. IT, like I said before, can check if the schema changes are there or data is fresh. That kind of stuff can be done by IT. But if we really want to judge or verify if sensor data was reliable, it needs to be owned by operations. But
Yeah.
what I can reveal is who should own it. But we did a survey last year where we surveyed that exact this question: who owns data quality? And we had close to 200 responses on that survey, and that was the main finding of the survey, is that for our prospects and clients or people we surveyed, is that it's not clear at the moment who owns data quality. That means it's not owned today. That means it falls in between the cracks, and I think that is really a problem. And so if you think about, it's now okay, or it's totally accepted and it's totally commoditized that we store data. We jumped from storing to consumption, like we rushed from after using storing in Pi to building models and then doing stuff with analytics. But it was never so. And companies and clients of us, they encourage their workforce to do more with data. That's the whole digital transformation kind of evolution. But that means companies, organizations are encouraging their workforce to do more with data, but it's not clear who owns the quality of data. That's a real big problem, and that is also why Timeseer is trying to play a thought leadership role here, and try to communicate to the market, to enterprises who have a lot of sensor data, by saying, look, this is really problematic. You're storing it, you're encouraging people to use it, but nobody has a clue if it's reliable, yes or no, if it's trusted, but you're encouraging people to work with it. And then you see indeed time that problems happen. And I think there's a big problem. And if I hope something will change over the next coming years, is indeed that CIOs, CDOs of large manufacturing companies understand that data governance, data quality is not an afterthought. And too often, data governance, if I see data governance happening in manufacturers, they start again with the relational data, the SAP data, the simple data. But if you look to a manufacturer, where do they make their money? They make their money with sensors, right? Because that's the heart of their operation. And that data nobody owns, and nobody knows if it's reliable. And that for me is a big problem. And that is the reason why I step out of bed every day, because that's exactly the mission what we have with Timeseer, is that data is so important for those kind of clients, and they don't have a clue if it's reliable, and nobody's owning it. And that is really close to our mission. So I'm really grateful that you asked that question, because that's so essential to what we're discussing here today.
Absolutely. Yeah. So I think as we kind of like wrap up here, I would like to kind of like get your thoughts on what you would say to manufacturing leaders who may be listening to this conversation, and they are thinking or really not sure whether they've got data downtime within their facilities, or they don't really know how to start being more proactive about managing the risk. What are kind of like those first steps that companies should take as far as ensuring the reliability and quality of their time series data is concerned?
It should start with knowing your baseline, making that first step, installing it on one of your servers, and check how good you score in comparison with your peers. If you know a baseline and you know if you score like 80% or 50% of data quality and where your problems are, it's typically a good first step where you can build your business case on. Because if you don't know how good you score, well, I would say score it, let it score, and that having that baseline is the most important step to start with. And then the next step is indeed when you know what your baseline is, you have to look, okay, if we score bad, where is the data used? So mapping your data products where data is used already, and there then you know how you're vulnerable, because then you know how untrusted data ended up in what kind of environment. Uh, and that's typically a very good first step. That start with the baseline.
Yeah, absolutely. Yeah, so we are going to provide links to your website, your LinkedIn and socials and all the relevant material to our audience on the description of this video and also on all the podcast platforms. But before I let you go, do you perhaps have some last thoughts for our listeners? Anything that we didn't touch on this episode?
Well, I hope you felt it, but that question related to ownership, like who's owning it, that is really what I want to to stop with today, because should be clear that if you store it and you consume it and you encourage people to use it, if you don't know if it's reliable, that you have a big mess, and that's really linked to that data liability side, right? So
Yeah,
you assume it's an asset, but it's not. They all say data is a new oil. Well, if it's not trusted, it's not oil. It's a liability, and I think that is the most important thing that I want as a takeaway here for today. Is if people understand that, they need to make the reflection like, okay, I need data quality cannot be an afterthought.
yeah, absolutely. And then just quickly, before I let you go, as a tradition on this podcast, I would like to ask our guests to give us a prediction on where they see AI, going in manufacturing in the next 2, 3 years, or whatever prediction you want to give us. Where do you see things going in the next few years?
Well, unfortunately, I don't see enough of AI at the moment in operations. If I see AI or AI being mentioned, too often it's still related to LLMs, language models, which are the most easy use case to start with. A prediction, or maybe more of the hope, that I'm hoping to see more and more really operational AI, closed loop AI in production. Things like digital twins, a closed loop, those kind of things. If that happens, and that's also a prediction I want to make here, I think by 2035, 10 years from now,
Mhm.
all data that's stored today will be verified before consumption. If that's happening, then also it's very safe to scale AI. So my hope is that indeed in the next 2-3 years we'll see more closed loop AI ending up in operations, and that is indeed what I hope to see more and more.
Absolutely. Bert, this has been such a fascinating conversation. I myself learned a lot on this conversation. So thank you so much for taking the time to, share your insights with the audience today. Really appreciate it.
You're welcome. Then thanks for having me.